Hey guys, I'm going to start by doing the few past exam questions that I forgot to do for the last exercise. With this first one here, question 6, it's actually about transformations. It's not about the last topic that we did, so I've actually put that in the wrong place. I will do it, but I'll do the other ones first. So let's look at this one here. Alright, now we've been given this function with this rule, and we're asking for, and we're being asked for the period. So remember, the period equals 2 pi on n, and our n value is just here. It's the coefficient of x, or whatever the unknown is in there. So n is pi on 5. So to work out what the period is, we just sub that n value in there. So 2 pi on 5. So that should give us 10. And the answer is C. There we go, we're done for that one. Now the next one down here, we've been asked for the period again, but we've also been asked for the range. So let's have a look at the period and just repeat what we did before. So the period is 2 pi on n. Our n value in this case is the coefficient of x. N value is 3. So therefore, the period equals 2 pi on 3. Awesome. We have the period, so that means the answer is going to have to be either A or B. Let's have a look at the range. Let's see what that'll be. So the range will be well, from the lowest to the highest, obviously. So let's work out what the middle is first. So we're starting at -3. That's our average. And we're going to be going up whatever the amplitude is. So +2. But we're also going to be going down to whatever the amplitude is. So it's going to be -2 as well. So that's going to give us the answers from -5. That's our lowest. And the highest is going to be -1, which would mean that the answer is A. Alright, so let's go back and have a look at this transformation one. So they haven't actually given us what the initial rule was or the rule afterwards. They've just given us some transformations or shown them there. Firstly, I'll do this the long way, and then we'll do it a shorter way. I just want to do it the long way first, so you know exactly what's happening through the process. So we're going from some graph which is y equals f of x. And after all these transformations, we're going to end up having y equals 1 minus f of 2x. Okay, so we're going from this graph to that graph. So I want to compare what's happening with the old y and the new y, the old x and the new x. So this is our new y, this is our new x. I'm going to move all the transformations that impact the y over to the other side. So I'm going to move my 1 over, I'm going to move the negative over as well. So we'll end up having 1 minus y Yep, so I've got that on that side. So now I want to compare my old y with my new y, but also I want to compare my old x with my new x. So I'm going to have y equals 1 minus new y, but I also have old x equals 2 times new x. Now to work out what the transformations are, we sort of need to know how we actually get to the new x. So we need to make our new x or new y. So we need to make our new y and new x the subject. There we go, so I'll rearrange that one. And with the x, it's going to turn into that. So this is showing that to get new y, we have to apply these two transformations. So there's a negative there, so that means we're going to be reflecting in the x-axis. So that's one thing we need to do. We also need to translate up 1 unit, and we need to dilate by a factor of half from the y. Okay, we just need to make sure we do that in the right order. So your dilation and your reflection doesn't matter which order it is, but make sure you do the translation last. So let's just start with reflect in x-axis, and then dilate by a factor half from y. Yep, and then we're translating up 1 unit. Oops, that was out of the screen. That's okay. So that took a little bit of time. What you could also do, just by looking at this rule here, you could see that whatever's in front of the x, that means you're going to be dilating by a factor of 1 on whatever that number is from y, which is this here. So you're going to be dilating up 1 on 2 from y. We can see this negative out the front. That would indicate that there's some kind of reflection. It's a reflection in the x-axis if it's out the front here. If it was a negative inside here, it would be in the y-axis. And this here is just a +1, isn't it? So it's moved the whole graph up 1 unit, so we're going to translate up 1. So these are the 3 transformations that you've got. We just need to work out which one of these graphs is going to be our new one compared to our old one here. So we need to do these 3 things to that graph, and one of these should be what we get. Alright, now I'm just going to start drawing on this one and showing each of these reflections. So if I'm reflecting in the x-axis, that means everything from one side's going up here, everything from up here is going down here. So it should look something like this. There we go. So we've done our reflection on the x-axis. That's finished. Now I need to dilate half from y. So I'm going to be squashing it in towards that y-axis. So we can see here that it's hitting at 1, isn't it? But we're squishing it in by 1/2. So that's going to turn to 1/2. This here is going to become 3 on 2. Over here is going to be -1/2 instead. Okay, so we've done this one now. The last thing we need to do is translate it up 1 unit. So we can see that your y-intercept is -3. It's going to be moved up 1 unit, so it's going to end up becoming -2. So it's going to be somewhere around here. Okay, so if we look down at these graphs, we need to make sure we have this shape, that shape there, but also it's shifted up a little bit, so it's y-intercepts 2. So that one has a similar shape. That one doesn't. That one has a similar shape. That one doesn't. That one also has a similar shape. Now this one here, see how the y-intercept's way down there at -4? That's no good, we don't want that. This one here, this instead of being dilated by a factor of 1/2, it looks like it's dilated by a factor of 2 or maybe even more, so it can't be that one either. This one here, we can see that the y-intercept is around about at -2. So it's got to be this one. The answer's got to be E. Alright, so we're up to 6E, which is solving trig equations. Now this stuff here is what you've seen in the previous chapters anyway. With the exact values table here, as Miss Thomas was saying, it's really important to remember it. But if you look at a few of these cells here in the table, I've changed a couple of the values. Now, they're not necessarily changed, it's just another way you can see it. So, normally printed is 1 on root 2, but that's the same as root 2 on 2. As you can see, I've changed it in those 2 spots. But this spot as well, instead of 1 on root 3, you might see it as root 3 on 3. They're the same thing. Alright, so let's start having a look at these examples here. So, basically what we're trying to do is solve. Now, in this case here, we're solving for x, that's our unknown. In this case here, we're solving for theta. Whatever the letter or the symbol is, that's what we're solving for. Now, basically what this one here is saying, and you can liken it to any other one as well, what is the angle that gives you, that for cos is root 3 on 2 in your exact value table? So we're actually trying to find out this value here. Now, every time I do it, I like to actually use a small unit circle that I draw over here. That's just because I like things to be visual. So this might help you if you're one of those sort of people. So I'll put my circle down. Now I want the angle when my cos length is root 3 on 2. So cos, again, hopefully you can remember from the other exercises, cos is our horizontal or our kind of x. And we want our cos length to be root 3 on 2. So to have that, the angle that we're going to have here is pi on 6. And we can check that in the exact values table as well. So we should go to cos and look for root 3 on 2. Cos, root 3 on 2. Our angle is 30 degrees or pi on 6, which is what I had written down before. So it is very, very important that we can remember this table, and Miss Thomas has given you a couple of tricks to do that as well. All right, now I've given the first angle that gives us that answer. It's asked for answers where x is between 0 and 4 pi. Okay, so it's not just going to be one answer here, there might be a few. Now in this unit circle, just the first rotation around, so from 0 to 2 pi, pi on 6 isn't the only angle that's going to give you this answer for cos. It's also over here as well. So what's this one? I've had a mental blank. 11 pi on 6. Awesome. So we know that x is going to be pi on 6 or 11 pi on 6. But those two answers are only in the first rotation around. So if I start from 0 and I go rotate around like this, there's my first answer, there's my second answer, but I need to go around to 4 pi, not to 2 pi. So I need to do another whole lap around. So I've got 1, 2, if I keep going around, here's another answer again. If I keep going around, here's another answer again. So there's going to be 4 answers if we're doing 2 laps around the circle. So the next one is going to just be another rotation added onto that. So 2 pi plus pi on 6. And another rotation added onto this one as well. So 2 pi plus 11 pi on 6. So if we just add these fractions together, that's going to give us our answers. Okay, so 2 pi is the same as 12 pi on 6, so this will give us 13 pi on 6. Again, 2 pi is the same as 12 pi on 6, so that's going to give us 23 pi on 6. And they're all our answers for that domain that we have been given. Let's move on to B. All right, so we're trying to find the angles where our sine reading is minus 1/2, and this is the domain that we've been given. So 0 to 5 pi, that means 2.5 rotations around the circle. I'm going to start off with my little unit circle here. All right, now the angles that make my sine length negative 1/2, remember sine's a vertical kind of component of your triangle that you're making. We need what angles? So you want your sine to be negative 1/2 down here, so that is going to be this angle here, which is 11 pi on 6, but also this angle here. So we've got pi on 6 from there, that's the angle between that bit there. That means this is going to have to be pi on 6 as well. So if that's pi plus pi on 6, that should be 7 pi on 6. Okay. So we've got our first 2 answers. So if we start from here and we rotate around, we've got 1 answer, 2 answer, but we need to do 2.5 laps. Keep going around, 3rd answer, 4th answer, keep going around, and we stop here at 5 pi. So we're going to end up having 4 answers. So theta is going to be 7 pi on 6 is our first one, and then 11 pi on 6. And then same as before, we need to add that 2 pi on as well, because we'd already done a rotation and then we're going around to that 7 pi and 6 again. Here we go, let's put our fractions together and we're finished. Okay, so 12 pi and 6, so that's going to give us 19 pi and 6 if we add them together. 12 pi and 6, that should be 11 pi and 6. Okay, 12 pi and 6 plus 11 pi on 6 is 23 pi and 6. There we go, and we've finished that one. What I might do before moving on is kind of show you what's happening with this question here, except solve it, or show how it works at least using a graph. So we're being told here that we've got that we want to know when sine theta is -1/2 over this domain here. So what I might do to start with is draw this graph for the domain that we've been given. So there's one cycle, so that must be 2 pi there. Another cycle, so that would be 4 pi here. And then we just need another half cycle to get to 5 pi. Alright, so there's the graph. Now what it's asking is, when this graph is at -1/2, now the amplitude of the graph is 1, so the highest it's going to go is 1, the lowest it's going to go is -1. We want to know when it's -1/2, so -1/2 is around about there. I'm going to draw a line showing where that is for the whole domain. Alright, now we're actually finding, because this is theta, so this is theta, we're actually finding where our graph is hitting -1/2. So it's hitting here, isn't it? It's hitting here, it's hitting here, and it's hitting here. And these are actually the spots where it's hitting that that point, or those lines. Okay, so this one here, that's our first solution. So this must be 7 pi and 6. This one here must be 11 pi and 6. Our one over here is going to be 19 pi and 6. And the last one within that domain is 23 pi on 6. So you can look at it using a graph as well. That might help some of you, maybe not for others. But whenever we're finding x-intercepts, or perhaps intersections between two graphs using circular functions, so your sine, cos and tan, you might need to use this sort of technique. Alright, so let's move on to C now. Now this one is a little bit different because the domain includes -pi, so it's going from -pi to pi. So some of it's kind of going backwards around the circle. Let's not worry too much about this just yet. I'm going to set up my unit circle first. Alright, so when is my sine length -1 on root 2? Now remember, -1 on root 2 can be the same as -√2 on 2. Exact same thing. And we're going to get that, if you can remember your exact value table and kind of rotate around the circle with it. We're going to have it here and here. So this would be 5 pi and 4. And we'd also have 7 pi and 4 as well. We have a little bit of a problem though, because if we look at our domain here, it's from -pi to pi. Now you can do this a couple of different ways. I normally just like to start at 0 and go forwards and then go backwards as well, because it doesn't matter the order that you're putting your answers in. So I'd start at 0 and rotate all the way over to pi, which is over here. And as I rotate, I can see that I don't actually have any answers. Okay, so I can't really give anything just yet. But I also need to rotate backwards because I need to get over to negative pi. So negative pi would mean I'm going from here, and negative pi is over in this spot as well. Except when we're rotating backwards around the circle, we've got negative angles as well. So this, like, yes, it's 7 pi on 4, but if you rotate around backwards, it's actually negative pi on 4. They're the same. And if we keep going around, this one is negative 3 pi on 4. So within this domain here, there was none from 0 to pi, but from 0 to negative pi, you've got a couple of different answers here. So we actually have minus 3 pi on 4, and we also have minus pi on 4. Finished. Okay, now moving on to the next one, we still have that same domain that includes the negatives, but it might look a little bit different because with this one, we've got a plus 1 here and a root 2 there. So it might kind of throw you a little bit, except really the only thing we need to do is move those couple of things across. So if we minus 1 and then divide it by root 2, let's see what it looks like. Okay, so see this now? That's something that you should see in your exact values table. Again, you can write it in a little bit of a different way as I did just before, which could be negative root 2 on 2. Either way, you're right. Alright, so when, or for which angles, do we have that cos length? So cos is negative over this side, so it must be here and here. So this angle would be, if we're going around the positive way, because we're going to have to, 3 pi on 4. And we don't need to go all the way around to 2 pi, we're just stopping at pi, but we also need to go to negative pi this way. This one's going to be minus 3 pi on 4. Because you're going around backwards, hence the negative, and pi's here, and you're going 3/4 of the way to pi. So our answers for x are negative 3 pi on 4, and also 3 pi on 4. Done. Okay, so this one here, the only difference is, instead of using radians, so as we've seen before, the pi's, we've been asked to give our answers in degrees. So it showed us that the domain's from 0 to 360 degrees, which is the same as 0 to 2 pi. So I'll ask myself, for what angles do we get our sine length 1/2? That's going to be pi on 6, which is here, but we're working in degrees, so that's 30 degrees. And the other spot that we get it is over here, which is 5 pi on 6. But in this case, we're working in degrees, so it's going to be 150 degrees. And there are two answers. Because if we go from 0 and rotate around, there's one answer. There's our second answer. If we keep going, there's only two that we get. So theta is 30 degrees and 150 degrees. Okay, the last one on this page. The difference here is you'll see that we have a 2 inside here. So now we're not necessarily solving for just theta to start with. We're going to solve for 2 theta. See how they've all been like x equals or theta equals? This time it's going to be 2 theta equals. So we're going to have a little extra step in there. Now, one thing that I want you to do, there might be other ways to do this, but this is the way that I do it. If ever you see a 2 here, or a 3 here, or anything there, I want you to multiply your domain by that. So we've got a 2, so I want to multiply the domain by that 2. So it's going to become 0 to 4 pi. If it was a 3, it would be 0 to 6 pi. If this was 1/2, it would be 0 to pi. The reason we're doing that is so we get all of the answers in the end. If you don't change your domain, you're only going to have half of the answers that you should have. All right, so let's do our circle. Forget about that 2 at this stage. When do we have this length for cos? And cos is negative in these 2 quadrants. So it's going to be here and here. I think this is the same as before, isn't it? Yeah, it is. So there and there. So this one, we don't need to worry about any negatives this time. It's going to be 3 pi on 4, because it's 3/4 of the way to pi. And this one here is another quarter along, so 5 pi on 4. There we go. Now, they're the 2 spots around the circle that we need, except remember, we need to now do 2 rotations around. So let's start our first rotation. So 3 pi on 4 is an answer for us. If we continue going around, our next answer is 5 pi on 4. Alright, we've done a full circle, so we're on 2 pi. But now we need to keep going. So 2 pi, and then another 3 pi on 4 is an answer. And if we keep going around, there's another 5 pi on 4. But we can't forget that we've already done a lap around. That's why we had that 2 pi. So let's put all those fractions together for now. Right, so this is 8 pi on 4. That's going to give you 11 pi on 4. Another 8 pi on 4. So that's going to give you 13 pi on 4. Cool. Now, hopefully we notice we've still got the 2 theta here. We're not actually solving for 2 theta. We do want theta equals. So to get theta equals, we're going to have to divide by 2 here. So if we divide all these by 2, we're going to get 3 pi on 8, 5 pi on 8, 11 pi on 8, and 13 pi on 8. Now, if we hadn't have changed this domain here from 0 to 4 pi, we wouldn't have ended up getting these 2 answers here. They'd be gone. We'd only have these 2. We needed to do that second lap around to make sure we got those answers. Now, when I said change the domain, it's just kind of changing it briefly, just so we get those answers. The real domain is this section here still. So let's have a look at all these answers and just make sure that they fit in between 0 and 2 pi. Yes, that's between 0 and 2 pi. Yes, yes, and yes. So we're all good. That's our answer. Alright, so with the examples on this page, what you'll see is that there's stuff like 0.7, negative 0.2. They're not stuff from your exact values table. So we can't really use our exact values table to help us answer these questions here. You are going to have to use your CAS a little bit, but that's okay because you need to practice using it. Alright, so even though it doesn't look like it's an exact value from the exact values table, we can still solve it using a pretty similar way. So I'm going to do my unit circle as I have been doing with all the other questions. And I'm talking about sine, so that's the vertical part, y, and we want that part to be 0.7. So I wasn't really doing this with the other ones, but that means your vertical length here is about 0.7. If the height of the top of your circle there's 1, that's around about 0.7, and it's going to be the same over here as well. So that means we've got these 2 angles here. I'm not exactly sure what those 2 angles are. That's why I'm going to need my CAS. So I could have been writing this with the other questions on the other page as well, but I just decided not to. When we're solving for x, what you'd be putting into your CAS is this. So negative of sine 0.7, and that's going to tell you what your angle is. So if you enter that into your CAS, what you're going to end up getting is this here. It'll tell you 0.775. Okay, and that's going to be our first part here. So So that angle there is 0.775 radians. It's not degrees, it's in radians. When you do this, make sure your CAS is set to radians. Alright, so it's given us that one. So it's saying that this angle here is 0.775 radians from there, which means that, like, these are symmetrical, so this angle here is going to have to be 0.775 radians from there. So if this is pi, this is going to be pi take away 0.775 radians. Yeah. So now what you might need to do is use your CAS again. So pi radians minus 0.775 radians, that gives you, once you put it into your CAS, 2.367 radians. So there are your two answers there, 0.775 radians and 2.367 radians. You can, because we are just solving for x, we can just use the solve function in our CAS. So I'll show you how to do this just now. So you'd go through the menus and get your solve function. So what we want to do now is put in what we've been given. So sine x equals 0.7, and we want to solve for x, don't we? So we're going to put that in there. Close our bracket. Now, if you press enter, what's going to happen is you're going to get every single answer as if the sine graph just continues on forever. So you're going to have an infinite number of answers. So it's going to pretty much be, you've got a sine graph that goes on and on and on and on and on forever. So if that goes on forever and you want to know where it's 0.7, let's just say it's here, you've got 1 answer, 2 answer, 3 answer, 4 answer, 5 answer, 6 answer, 7 answer, 8 answer. It's going to keep going. You're going to have an infinite number of answers. We don't want that. We only want the ones from 0 to 2 pi. So what we need to do is tell the calculator the domain that we want. So hopefully you guys remember, but there's that vertical line. I can't remember exactly where on the CAS it is, but you need to press the blue button, control I think, and then find that little blue vertical line. I'll find out and put a photo on your lesson plan, but most of you guys should remember. And now we need to specify the domain. So it's going from 0 all the way to 2 pi. If you enter that, it's going to give you those two answers. So either way you want. I'd probably say that I'd prefer doing that, but it's good practice doing that way as well. If you got your CAS, you may as well use it to be fast, so just do that. Alright, next one. Same sort of thing. So let's get our unit circle happening. We want our cos length to be negative 0.2. It's negative over here. We want it to be like 0.2, so something like that. So not very long. So that means we've got these couple of angles here. Alright, now again I'm going to need to use my CAS. So I want to solve for theta. Same process as before. And if you put that into your CAS, it should give you the answer 1.772. So this here is 1.772 radians. If you want to remind yourself, you can put a little r up there, or a c. I think they can use c's as well. Now let's look at the domain here. It's only from 0 to pi. So 0 all the way to pi. We've only got one answer, don't we? We don't need this one at all. It's not within our domain. So we're finished. Okay, again, we're working with degrees here. Most of the time you're going to be working with radians, but it's important that we can use degrees as well. But same sort of thing in terms of solving it. Right, so we want our sine, which is a vertical component, to be negative 0.3. So negative 0.3, something like that, which means that we're going to have those two angles there. Now I'm going to need to use my CAS to find out what those angles are. So I'll leave that for the minute. Okay, I'm going to enter that one in. Now I scrubbed that out because I don't want degrees just yet. I'm going to get the radians answer and then convert it using the calculator to make it faster. So the answer that it should give you is 0.305 negative. So that's telling us, because it's a negative there, it's actually telling us about this angle here. So it's saying that from here to here, that angle is 0.305 radians, and it's in the negative direction. That's why we're going that way. So I don't necessarily want those negative answers because that's not the domain that I've been asked for. I want positive. So that's okay. We can use our answer to work it out. So I know that this is 0.305. This is symmetrical, so this has to be 0.305 as well. Oops, can't see it. That has to be 0.305 too. I know that all the way around to there is pi, so here has to be pi plus 0.305. So one of our answers is going to be pi plus 0.305. And over here, this is 2 pi, isn't it? All the way around to 2 pi, but we don't want to go the whole way. So this here is 2 pi minus 0.305. Right, now if you work out what they are in decimals on your CAS, you should get 3.447 and 5.978. The problem with the answers that we have here is they're not in degrees, they're in radians. So we're going to have to make a change using our calculator. Now, you need to press the catalog button. It looks like a little book that's opened. You'll click on that, and then you'll scroll down to where it has a little arrow and then DD. That changes any of your answers to decimals. Now again, I'll take a screenshot of what that looks like as well, so you'll be able to do it yourself. But once you've done that, your answers are going to be this. There we go. Okay, last one, finally. Now the difference with this one, similar to the other page, is we have that 3 there. It's going to change our domain. So instead of having our domain from 0 to 2 pi, we need to make it from 0 to 6 pi. Okay. So let's forget about the 3 just for the time being. Let's set up our circle and see where this angle is. Alright, so cos is positive here and here. We want the angle to give us a length of 0.4, so that's a length of about 0.4. So that will mean this angle and this angle. Okay. So again, we're going to use our CAS to find out what that angle is, because it's not an exact value. So we'll set this up, and it's not just going to be x, it's going to be 3x because we're solving for whatever's inside here. And once you've put that into your CAS, it's going to give you the answer 1.159. So this one here, this angle here is 1.159. So from there to there, 1.159, which means from here to here, that has to be 1.159 as well. So the next answer is 2 pi minus 1.159. Now if you put that into your CAS, the answer that it'll give you is 5.124. So that one's 1.159, 5.124. But remember, we're not just going from 0 to 2 pi. We're going from 0 to 6 pi, so we're doing 3 laps around the circle. Alright, so let's start here. One answer, keep going around. 2 answers. Let's get back to the start. So we've done 2 pi. We've already got 2 pi in the bank. Let's put it there. We need to keep going around. So this answer will be 2 pi plus that 1.159. Remember, we've still got 2 pi in the bank. Go around and we get back to here. So that was 2 pi plus 5.124. Alright, so we've done 2 laps around. We've got that first answer, second answer, third answer, fourth answer. We're going to need 2 more. So we've done 2 laps around. So now we're on 4 pi. 4 pi in the bank. And now we need that extra section there. And there's our last one. So that's 4 pi plus 5.124. Alright, and that is not quite it. You'd have to add these together. You've got your CAS there, so add that together, that, and there's all your answers. There should be 6 of them. Alright, so let's maybe have a look at these next couple of questions. Alright, so these are those past exam questions. So we'll have a look at some of the past exam questions now. So this looks quite similar to some of the questions we were just doing before, except you'll see there's a sine and a cos there. That seems a little bit confusing because we haven't really seen that kind of thing, especially in the examples that I just showed you then. I hope you guys remember from last year and possibly before then, I think Miss Thomas touched on this as well. This rule here, it's important to remember this because we actually need it for this question here. Alright, so if we rearrange this one, we can get the sine over to the other side, which will then give us this. What you might notice is, yeah, but how are we going to use this rule when you've got sine and a cos like that on this side, but then you've got the opposite over here. You've got the cos at the top and then you sine down the bottom. You still can use it. If you take the inverse of both sides, so if you sort of do this, remember that's going to flip your fractions around. So that's going to give you 1 on root 3 on this side. So that's an exact value. Then over this side, it's going to flip that fraction. So it's going to be sine x on cos x. Now hopefully you can see that the sine x on cos x here, same as the sine x on cos x here. So we can actually change that to tan x. So it's going to be tan x equals 1 on root 3. That's one of your exact values. It can also be written as root 3 on 3. Whichever you like. I'm just going to leave it like that. And now we're back to the kind of thing that we were doing in the examples, except this time it's tan. So I'm going to put my circle here, but this time I'm also going to add that tangent line that goes vertically along here. So we're being told that our exact value for tan is root 3 on 3. So that should be this angle here. So that length is going to be root 3 on 3. And the angle that we need to get that is pi on 6. Okay, now with tan, it's positive here and here, so this angle kind of also goes across like that. Now let's have a look at our domain that we've been given from negative pi to pi. Now our x values, one of them, if we go around this way, is going to be pi on 6 as we found before. But we need to go around to negative pi as well. So if we start here and go around to negative pi, this is going to be the angle that we need. If that's pi on 6, this one here has to be a distance of pi on 6. So that's going to mean that this one is 7 pi on 6. Because pi plus pi on 6 is 7 pi on 6. The problem is, I just gave the positive one. We're going around backwards. So we don't really want 7 pi on 6. If we're going around backwards, that's going to end up being 5 pi on 6, except negative. Okay, so there's one answer, and there is our other answer as well. So the real tricky part was using this rule to make it into a tan. All right, let's move on to the next one. Now with 22 here, I'm going to do A, but we'll leave B for another time because we haven't looked too much at horizontal translation yet. So we will come back to that one. We will do this one though. So A wants the range and the period. So let's sort out the range first. Now remember, the range is from our lowest y value to the top y value. 4 is our average, like right in the middle. So we start at 4. If the amplitude is 3, that means we're going to go up 3, but we're also going to go down 3. So that's going to give us a range of lowest first. So 4 minus 3 is 1. 4 plus 3 is 7. So that is our range. We also need the period as well. That's what I asked in the question. Alright, so period is 2 pi on n. Our n value, where is our rule, is pi on 2. So if n's pi on 2, that gives us this, which means our period is going to be 4. So there's one of your answers, and there's the other one. There's still a couple more. Oops, was that in the screen? I hope so. There it is anyway. There's still a couple more past exam questions. Alright, so 42, same as what you're doing before, except it's kind of giving you a bit of a funny domain. So from 2 pi to 4 pi. Before we were kind of going from 0 to 2 pi, 0 to 4 pi, negative pi to pi. Not so much the same as that, but that's okay. I don't think it's really going to change too much. There's my circle. It's a negative, so sine's negative in these two quadrants, and it's going to be negative 1/2 at that angle and that angle as well. So like this bit, this length there is 1/2. Alright, so this angle here is going to be, actually we'll do this one first. So you've got all of pi and then another pi on 6, so 7 pi on 6. This one here is 11 pi on 6. Alright, so I didn't really touch on what's going on here before either. See how the coefficient's 1/2? So instead of using this domain, we should be timesing it, shouldn't we? So we're going to change the domain to be from pi to 2 pi, because we're timesing it by 1/2, because 1/2 is there. Now inside this domain, so we're all the way up to pi, so we're going to start here and then there. We have those two answers. So we've found out that x on 2, because that's what we're solving for inside here, is going to give us 7 pi on 6. That's also going to give us 11 pi on 6. We want to solve for x. We need to times these by 2. And we're done. Let's have a look at them though. Are these between 2 pi and 4 pi? We can forget about our kind of like change domain there. We want this one. So are these between 2 pi and 4 pi? Yes, that's over 2 pi. And yes, that's under 4 pi. So they're inside there. All good. Last one. Same sort of thing before. They've given you the domain in a different way, but that just means from 0 to pi, which you guys would know. Just making sure. And we need to move this 2 as well. So let's move it. Cool. Now, with this domain here, remember there's a 2 there, so we're going to multiply it. So we're going to change it for now from 0 to 2 pi. And we want to find where our cos is negative root 3 on 2. Alright, so cos is negative here and here. It's going to be this angle and that angle as well. So this one would be 5 pi and 6, and that one is 7 pi and 6. Alright. So if we do a lap around from 0 to 2 pi, there's one answer, there's the other one. So 2x equals 5 pi and 6, and also 7 pi on 6. But we want to solve for x, not 2x. So 5 pi on 12 and 7 pi on 12. And we're done.